Hey class. Okay, this is my first flipped video, so bear with me if it's not perfect. So this video is going to cover solving literal equations, which you may not know what a literal equation is yet, so let's look at the next slide. A formula is an equation that states a rule for relationship among quantities. You guys know what formulas are. Something like area equals length times width. That's a formula that you are all very familiar with, right? Well, a formula is just another word for a literal equation, okay? So anytime I say literal equation, all I mean is an equation that's just full of letters, okay? It's unsolvable the way it is, and it just literally states some sort of relationship between quantities. For example, this states the relationship between length and width is that when you multiply them, you get area. So here's an example. We have in a formula, D equals RT. D is for distance, R is for rate, T is for time. So this is a formula showing how to get the distance if you have someone's speed and how long they are going somewhere. So it says right here, you can rearrange a formula to isolate any variable by using inverse operations. This is called solving for a variable, okay? So basically what they're saying is if you want to take this equation, D equals RT, and instead isolate the R, we have the power to do that, okay? And we're going to do so by following these steps down here. So step 1, locate the variable you are asked to solve for in the equation. Step 2, identify the operations on this variable and the order in which they're applied. And then step 3, just use the inverse operations to undo these and isolate the variable. This is no different from how we solve normal equations. There's just no numbers. Okay, so let's see what this looks like. For D equals RT, if we want to solve it for R, it said first identify what you're solving for. Well, there's the R. We did that. Then it says identify the operations that are occurring on that variable. Well, the only operation that's happening here is that we're multiplying by T. So we just need to make sure we undo that by doing the opposite operation. So for us, opposite of multiplication would be division. So we're going to divide both sides by that T, just like we would if that said 3R and we divide by 3. It's the same exact process. So keeping my sides separate here, on the right-hand side, T over T, even though those aren't numbers, we know that those cancel and leave us with just the R, okay? On the left side, D over T, well, we can't actually divide that out. We don't know what D is, we don't know what T is, so we're just going to leave it as D over T. That is your answer. We've officially isolated the R by itself. We've made ourselves a new formula that says the rate is equal to the distance over the time. Okay, that's what this lesson is all about, moving formulas around so that a different variable is by itself. Okay, so let's try a problem over here on the right-hand side. This says solve D equals M over V for M. They're wanting us to isolate the M in this density formula. So I need to identify what operations are happening. Well, the M is being divided by V. So what's the opposite of division? Multiplication. So I'm going to multiply both sides by V, okay? So on the right, these two V's here and here cancel out. All I've got left is this M. On the left-hand side, V and D, well, we don't know what V is, we don't know what D is, so just to show that they're being multiplied, we're just going to squish them together. We accomplished our goal. M is by itself, so mass equals volume times density. Okay, simple as that. There's no math involved. It's simply knowing what inverse operations to use to undo what's being done. Okay, so let's see some more examples. It gets a little bit more intense, but not too bad. So looking at the top here, it says the formula for an object's final velocity, F, is F equals I minus gt, where I is the object's initial velocity, blah, 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 blah. This is a whole lot of extra information when all they're wanting us to do is take this equation, and then right here it says solve for I. Okay, so I'm even going to just rewrite this so that I'm not getting confused by all of the identifiers of what this formula is talking about. So if they want me to get this I by itself, okay, I just need to get rid of this minus gt. So I think, okay, what's the opposite of minus gt? Plus gt. I'm going to do that to both sides. Okay, keeping these separate. On the right, a minus gt and a plus gt, those are gone. All that's left is the I like I want. On the left-hand side, f plus gt, well, those are not like terms, so I can't actually add anything. I just have to write those two things down. So now I have a new formula for I. Now I know that the initial velocity is equal to the final velocity plus acceleration due to gravity and time. Okay? One more example. That's a one-step example. It says solve 5 minus b equals 2t for t. Okay? So again, I just need to get that t by itself. Here's the variable I want by itself. So I need to get rid of the 2. It's being multiplied, so I'm going to divide. What's special about this one is that you have to divide the entire left-hand side by that 2. 2's cancel here. So I can either write it like this. Oh, whoops, not a 2. Sorry. B, there we go. I can either write it like this, or I can try to split that 2. This is completely acceptable, but you could also split the 2 as 5 over 2 minus b over 2. And that would also be fine to equal the t. Either one, they really mean the same thing mathematically. Okay, but again, each one of those we just solved in one step. The top equation, we just added that gt over. The bottom equation, we just divided by 2. So let's talk about some multi-step equations. So this top one says area equals base times height over 2. We're going to solve it for b. You'll notice this is the area formula for a triangle. They're wanting us to actually solve it for the base. So I need to identify where my variable is, right here. And now I need to undo all the operations. Well, I see it's being multiplied by the h, it's being divided by 2, and I need to undo both of those. I'm going to start with the 2. As I talked about in class one time, it's kind of like a bodyguard right now. So because it's being divided, I'm going to multiply. So now I have 2a equals, 2's cancel, bh. Trying to get b by itself, so now I need to get rid of the h. If it's being multiplied, I need to divide it. So 2a all over h equals b. I can't actually work any of this out, so that it's all just going to stay in letter form. Okay, this next formula should look familiar. It's the formula for the perimeter of a rectangle. They want us to solve it for w. I need to get that w by itself. Again, we're going to have 2 steps here instead of 1 step like on the last slide. So I need to first identify what's happening. Well, it's being multiplied by 2, and it's being added to this 2l. Okay, so let's undo with addition first. So let's subtract 2l instead on both sides of my equal sign. That leaves me with p minus 2l. They're not like terms, so I can't actually work anything out. Okay, those are gone. All I have left is the 2 that's with the w. Well, it's being multiplied, so I need to divide. Again, like that last problem, you can either just leave it underneath the whole top part, or you can take that 2 and split it up to be with the p and with the 2l, but you don't have to. You can also just leave it the way it is, which is what I'm going to do. Okay, just a few more. This one actually shows how to deal with distribution. Okay, so it says solve 3 times the quantity of y plus 12 equals 2x for y. Well, that y is on the inside. Okay, so there's actually 2 ways to do it. That's why I have 2 problems up here. But in either case, I'm going to solve for y. In the first case, I'm going to go ahead and distribute that 3 ahead of time. Okay, so 3 times y is 3y, 3 times 12 is 36, and that equals 2x. Okay, if I'm trying to get to that y, I'm going to start undoing everything. Right, here's my y, so I'm going to subtract the 36. So 3y equals 2x minus 36. And then I'm going to divide by 3 so that y equals 2x minus 36 all over 3. Okay, that's one way of doing it. Works just fine. Okay, you can also take care of the 3 ahead of time, right? If distribution is really just multiplication and we're trying to undo that, let's just go ahead and divide right off the bat. Okay, that'll cancel that 3 in the front, leave us with y plus 12, and on the right side, 2/3 x. At this point, all that's left is subtract 12 from both sides. So y equals 2/3 x minus 12. Okay? Again, they are the exact same thing. They may not look like it, but if you picture this one over on the left, taking this 3 and splitting it up to each one of these, that makes 2/3. And then 36 divided by 3 gives you the 12. So they're essentially the same thing. Okay? So either method would work. All right, so this is a little bit more complex. We're just getting a little bit more difficult each time we go. So it says solve for x. Here's my x. I need to start undoing all these operations. It's being multiplied by y squared and divided by w. So let's multiply by w. Always opposites. So xy squared equals sw. Still trying to get x by itself, so I need to divide by y squared. Notice I didn't do anything with the square. I just went ahead and kept it on that y. Okay? Another example. KE equals 1/2 mv squared. It says solve for v. Okay, here's my v that I'm trying to get by itself. Notice I'm not circling that square. I need to first get rid of the half and the m. I'm going to start by multiplying by 2 to get rid of that half. So 2ke equals mv squared. Okay, got to get rid of the m. It's being multiplied, so I'll divide. Last step is to get that v truly by itself, which means eliminating that square. The opposite of squaring something is to square root it. So my final answer is the square root of 2ke all over m, and that's equal to the velocity v. Okay, this problem over here on the right, we're trying to isolate the b, which is over here at the end. So I need to first get rid of all the stuff that's on the left-hand side. I'm going to subtract a off. So p minus a is going to equal n minus 1 all times b. Well, again, even though it looks funny, it's just multiplication. So we just need to divide by that whole thing it's being multiplied by. So p minus a all over n minus 1 equals the b. All right, now we're actually going to skip this one on the left, number 5. If you'd like to do that one later, feel free. I'm going to solve this Fahrenheit problem, and then you will have a few that you can try on your own. So number 7, the United States uses the Fahrenheit system for temperature, whereas the UK uses the Celsius system. The formula F equals 9/5 C plus 32 can be used to convert from temperatures in Celsius to Fahrenheit. But it's asking us on part A to solve the equation for C. So this formula as it is gives us Fahrenheit. We want to change it to where it gives us Celsius. So I need to start undoing, right? I'm going to rewrite it here. I want to get that C by itself. So first thing I need to do is subtract the 32 that's being added on. So F minus 32 equals 9/5 C. Now here's where a lot of you really should pay attention. We want to get rid of 9/5. If it's being multiplied by C, we essentially want to divide, right? But how do you divide fractions? You multiply by the reciprocal. So we're going to multiply by 5/9 on both sides. Okay? So that gets rid of these fractions. So I'm left with the C like I want. But on the left-hand side, I essentially need to distribute this. For time's sake, I'm just going to write it as a distributive property problem instead of actually working it out. That would be the new formula for Celsius, which allows you to answer part B. It says if the average human body temperature is 98.6 degrees Fahrenheit, what is the equivalent body temperature in C degrees Celsius? Well, now I can take this Fahrenheit and plug it in for F. I would subtract 98.6 minus 32. I'd get my answer, and I'd multiply by 5/9, and that would give me the Celsius. All right, so here's 4 that you can try on your own. They're not quite as crazy as some of the other ones, but they're essentially going to give you an equation and then what to solve for. So this first one they're asking you to solve for R. They want you to get this guy by itself. Okay? So take a minute, pause your screen, screenshot it, do what you need to do so that you can complete these 4 in your spiral for tomorrow so that we can hit the ground running with literal equations. Thanks for hanging in there.